Here we go. Lesson 10.5. It is about angles and intercepted, not footballs, but arcs. All right. We're looking at something we saw in the past, which is inscribed angles. Hopefully this first idea is a review. You shouldn't even have to copy it down. If I have an inscribed angle, it is 1/2 the measure of the arc it intercepts. So notice how the angle cuts off that arc. So we say it intercepts it. All right. By the way, this angle, another way to describe it besides inscribed is you could call it a chord angle. Okay. Though we're going to use that specific phrasing for something else. So this one here now is called a tangent chord angle. And notice we have the tangent and the chord. And then notice we have an intercepted arc. So the relationship of measure of angle Q is, as you might expect, 1/2 of the measure of the arc PQ. Okay. So let's look at an example of that. Here we have FE is the tangent at E, and the measure of arc DE is 80 degrees. Find the angle measurement. Well, 1/2 times 80 equals 40 degrees. All right? Okay. Now we have a chord. Yes, in this case the chords aren't meeting on the circle at the vertex, but the intersection is in the middle of the circle. Not directly the middle, like the center, because then we'd call it a central angle, but somewhere in the interior. So the measure of angle P is going to be related again to the arcs that are intercepted. Again, there's one arc, and the other arc is EF. All right, so if I take, again, that 1/2, just as you might expect, and then I take the two arcs, CD and EF, add them up, and divide by 2, right? Then I've found, in essence, the average of the two arcs. And that's exactly what angle P is. Angle P will always be the average of the two arcs that it intercepts. And that's kind of what the chord theorem says. The average of the intercepted arcs is the measure of the interior angles. You don't need to ever cite chord theorem. I don't think we ever use that in a proof per se. Use it mostly in problems that you solve. So again, here we have a situation, 2788. So what is x? Well, again, I'd have to take 1/2 of the sum, which is 115 degrees, which is 115 over 2, which I think is 57.5. All right? Now this is a little bit more challenging problem, because here we know one of them, don't know the other one. So again, 21 plus y, half of it has to be 72. Give you a moment there to solve that one out. I think the first thing I like to do in these problems is multiply by 2. That cancels the 1/2 for me. So I'm left with 21 plus y equals 144. Subtract the 21 and we get 123. All right? So we know this angle must be 123 degrees. All right. I'm not going to solve this one, but note here, the angle that we're initially find is here. Our goal is here. Note the relationship between these two pieces. Yes? They're supplementary. So once you find that angle that would be called that chord angle, then you want to subtract from 180. All right, one theorem, and there's like three variations or two variations after this on the same theme. Here we've got the angle. Notice now, this is on the exterior, outside of a circle. But again, it intercepts two arcs. So how does the measure of angle V, well, guess what? The 1/2 shows up again. But this time, instead of adding, which would then be an interior, we are going to subtract. Make sure that you always subtract the larger from the smaller. Okay? All right, so it's the average of the difference this time between the arcs. And that would be, again, with the secant. And now we have a secant tangent, right? But note again, we have an arc, we have a second arc. So, same thing. To find the measure of angle C, guess what? You do 1/2 of the difference between AD and BD. So it's similar to the one that we just did. As is our last one, tangent. It's kind of like a satellite problem. Note here is Earth. Right? In this case, our two arcs together make up 360, right? Because there's no other left piece. So in these problems, it's kind of weird because they don't have to give you two numbers. They can just give you one number to find it. But to get the measure of the angle, which is outside the circle, exterior part of the circle, you have to take 1/2. Again, always the major arc or the larger arc, EH. In this case, minus the measure of the smaller arc, EH. Okay, and this is the major. I should have 3 letters in this case. They didn't give me another point out here. They probably should have. Feel free to throw a point in there, like in this case, G, right? And so then you would say EGH. And this is the minor. All right. So here's an example. We got an ice cream cone. X is this angle here. How do I get that measurement from the 78? Well, first thing, I don't have anything to subtract 78 from, right? So it's something minus 78, and then I have to take half of it. Well, how do I get that? Well, guess what? It's the rest, right? So 78 minus 180, or 360, is 282, I think. Let me check that. Yeah, that's right. So 282. And I'm going to subtract 78 from that. And so I take 204, which gives me 102. All right, so that's what X is, 102 degrees. Doesn't look like 102 degrees. Let me make sure I did my math right here. Yeah, okay. I guess that's a bad drawing initially of 78 degrees. That must not be 78 degrees there. Okay? All right, and you're going to get various problems you know, like that. Again, subtract those two arcs, divide by 2, same thing here, except for the fact that this time they give you the angle, so it's 125 minus z divided by 2 is 32. This problem here, this type of problem is the trickier problem because we have two unknowns and we have an interior and an exterior. So in this case, I have to set up a system where I take and subtract the two angles, divide by 2, and that should give me 24. And then when I add the two angles, I get 65. Now I can solve these two triangles, these two equations, because x minus y should now equal 48, and x plus y equals 100 and, what would that be, 30? Okay, so now I have a system of equations, but that, I think most of you could solve that pretty quick and find that. But don't be buffaloed, and good luck in finishing 2.5. Again, 10.5, sorry. It won't be due until, I don't think, Monday night.